Welcome back, nerds. Today, we are going to start 4.3. And 4.3 might just be one day, but we'll see. We are going to start giving ourselves the idea of some right angle trigonometry. So right angle trig. Now, the good news is that 99% of the trig that we do will be with right angles. There's only a couple small situations where we do trigonometry with non-right angles, at least in our mathematical worlds. But we're going to look at this. Now, when we draw our triangles, eventually it will matter the orientation that they go, but I'm always going to draw quadrant 1 triangles unless it's specified another way. When I say a quadrant 1 triangle, that means I'm imagining the unit circle, and the hypotenuse is my radius. So it'll go out in this direction. A quadrant 1 triangle will always go out here to the circle and then straight down. It's that bow ties and butterflies idea. So here we have a lovely, wonderful right triangle. Now, so far we have looked at the idea of sines and cosines and a little bit of tangents as merely representing points on our unit circle. There's an x distance that we've gone here that we'd call the cosine. There's a y distance that we've gone up called the sine, and then if you take that ratio or that fraction, you get the tangent. Okay, from this, if we were to talk about this angle, do you guys agree it'd be weird to call it this is the angle that formed that triangle? If we're thinking about quadrant 1, this is a weird choice. Because normally, and you don't have to draw this, but if this is the coordinate plane, we normally start here and then rotate up, right? Some amount of angle. So we're going to go ahead and just mark this as our angle right now, and we'll use theta. That's pretty standard. Alpha is also a good one, but we'll use theta here. Now, everything that we do right now is going to happen with respect to that angle theta. Now that, however you interpret it, theta is where we're looking from. We're standing right there. Now, on this triangle, it's not a trick question, how many sides are there? There's 3 sides. And if we're standing at angle theta, can you tell me which side is opposite of this? The vertical side here. So I like what you're saying there, but it would only be the queen if it's a 30, 60, 90. But I agree with you. Do we all agree that this side right here is opposite from this angle? So we're going to call this the opposite side. Okay. Now, we have another word that we're going to add in here, and it's going to be adjacent. Now, what does adjacent mean? Next to, but here's the issue. How many sides are next to or neighbors with this angle theta? One is the hypotenuse, and one of them is adjacent. Which one of these is the hypotenuse? The diagonal or the horizontal? The diagonal. Convince me. Why? It's opposite from this 90-degree angle. It's the longest side. So this side up here is my hypotenuse. And it means that this must have been the adjacent side all along. Okay. As we deal with this, the weirdest thing that happens, everything that we've just said is from that angle theta. That's like our point of view. If I had looked from up here, these would have switched places, right? And we would have had to say from this angle up top, this is now the opposite side. You have to cross the whole triangle. Be careful when you're drawing them. Simple sketches will be crazy helpful. Now, we are going to deal with this triangle, and it's going to help us make sense of everything. So what we're going to do throughout this chapter is, it's kind of strange that we do this, but yesterday we defined sine, cosine, tangent as x, y, and y over x. That's how we define them, or y, x, and y over x, depending on how you want to go through it. We're going to see there's a bunch of different ways that one can think about these things, sines, cosines, and tangents, and we're just going to slowly start adding different ways to think about them. So the x and the y coordinate is completely fine. That's awesome. But we get some new definitions today. So we're going to give ourselves the right triangle definitions. Okay. Now, we're going to start being a little bit more rigorous than maybe we have always been. And all that means is we're going to be really specific. There's not going to be any ambiguity in the way that we write things down. It'll be a little bit more formal, but let's jump right in. We're going to begin with these definitions by saying, let an angle theta be an acute angle. And what do I mean by acute? Less than 90 degrees, but we're doing trig right now, just as a reminder. So less than what? Less than pi halves. Now, realistically, I like the 90 degrees. That's what I think of as well, but less than pi halves. If this is true, then we have the following definitions. Okay, that's it. Theta is just some angle that's acute. Okay, so we're going to stay consistent in the way that we write this. If I want to talk about the sine of theta, Davian, big moment here. Do you remember that Lakota chief's name? I should have made it a bigger deal. I'll write a book tonight. That's not true. What's his name, everybody? Sohcahtoa. Now, if you want to put this up here, I'm okay with it. S-O-H. That's his first name. So, Ka, C-A-H. Toa, T-O-A. Now, Dave, and it's going to feel like I'm picking on you today, and I just want you to know that I'm not. With thinking of trig stuff that we've seen, any guess on what these three capital letters might represent? Sine, cosine, tangent. Okay, Sohcahtoa. With these three words here, what do you think O and H represent? Opposite and hypotenuse, right? And A is the adjacent side. If you can spell Sohcahtoa, we always have these. The sine of theta, the S in this, is O and H. What are those sides again? The opposite, OPP, over the what? Hypotenuse. Now, we're going to pause really briefly. On the unit circle, what was the radius or the hypotenuse always going to be? Anywhere on the unit circle, it's a circle with a radius of what length? 1. So if we looked at this as a coordinate plane, for example, and I said, what is the sine? It would be the opposite length, which is just some y value, right? Over 1. And it's just y, which is exactly how we defined it yesterday. This is just a clarification when the radius isn't 1. It's the exact same thing. We're just allowing for the radius to change. Okay, sine is opposite length over the hypotenuse. What's the cosine of an angle theta? AH, what do those represent? It is the adjacent, which is ADJ, not adjective, but adjacent, over the hypotenuse. Which, again, I just really want to stress here, if this were the coordinate plane, my cosine is just the x value, and it'd be how far over 1. And it's just x over 1 is just x, and that works the exact same. One more that we have to, or that we get to add in here, what's the tangent of theta? Opposite over the adjacent, TOA. And you're okay to say op over hype. I just wanted to make sure. Oh, you're not okay to say that, but I didn't even notice it the first time either. Opposite over adjacent. Okay. Nothing new yet, right? I want you to give me the new definition and put them in the right spots for, I'm going to give them to you in a weird order here, cotangent, secant, and cosecant. I want you to match them up with where they should be matched up and write those three definitions right here. We'll meet back up in about 45 seconds. You can use your diaphragm to pull air into your lungs, and then while exhaling and changing the shape of your throat and mouth, communicate ideas with your neighbors if you need. The hypotenuse over the opposite. Which again, if this were the unit circle, this would just be 1 for the hypotenuse over y, which is exactly how we defined it yesterday. What pairs up with cosine? Secant. And how do we define secant, Wisha? Hypotenuse over adjacent. Addison. I was going to say and, but we just transitioned. What's cotangent then?
I don't know if I'm right. I did hypotenuse over opposite, and that, all of that over hypotenuse.
Okay, so we're going to pause real quick. Sine is the reciprocal of cosecant, right? And are you okay with that, or are you just accepting that I'm saying it? Yep. Sine, when we defined it yesterday, we said sine is y, and then we said cosecant is just 1 over y.
Yeah.
So these are just reciprocals. And you had this one right, yeah?
Yeah.
And this one right?
Yeah.
What's the reciprocal of tangent?
Oh, it's reciprocal? I thought it was y over x.
So it would be, but if we look at this, if tangent is y over x, then this would be x over y. What's x here? So like if we think about this as an ordered pair, is this X or Y right here?
Y. X.
I agree with you. And this is
And that one's Y.
Y. So if we define this tangent as Y over X, which is what we did, what's the cotangent then? If we do X over Y instead. Good. Yep. Awesome. I'm so glad that I asked you about that. Good cleanup. All right. Nothing crazy going on. Sweet. Now, as we look at these, we're going to just, I'm going to throw you right in the deep end and see just what we come up with. We've already done the unit circle, which is going to make this super duper easy. I just want to point out a few things. Using these definitions and just these definitions, I'm going to give you a couple triangles that I want you to think about. And I'll just say, use these triangles to evaluate the following for me. I don't want you to just use your unit circles. I want you to actually make the triangles that I'm about to make, and I want you to play around with them, okay? Cool. And this is realistically probably going to be the end of the video because I'm just going to give you guys a few minutes to mess with these. So here we go. Little editing magic to shorten it. So on part A, I want you to use that blue triangle, and I've only given you one length on it. Once you get this one, and we have 6 minutes left, so I think you'll get through both of them, I'm going to have another triangle up here once you get through. Just look up at the other triangle, and I want you to just answer these two questions. We won't have formal homework tonight. Cool, cool? Cool, 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 cool. All right, I'm going to draw the other one. Okay, I'm just talking so that there's a little bit of a narration here. Once you get A, check with me. You can check with your unit circle too, but I want you to do the triangle first. And then B is also here, but I'll come check with you. If you have A done and you're confident, I want you to try B as well. Just so you know, this letter right here that looks kind of like a fish, alpha.